Alright, let's look at the homework 7.3, problem number 5. Alright, so since we have a square root of a squared minus x squared, so this is the pattern for x equals a sine of theta. So we're going to let x be a sine of theta. Alright, then we can just go through the usual drills. Take the derivative of x with respect to theta. That's going to give us a cosine of theta. And then we multiply through by d theta. We have a dx is equal to a cosine of theta d theta. Alright. So this can be rewritten as, so we have an integral here. Alright. And since 9 is just a constant, so I'll place it in front. Alright, so we have x squared, so it's going to be, actually this is going to be a too. I'll probably put it inside. So we have a squared and a sine squared of theta. Right? Then if you plug a sine here, you're going to get a squared, so you can pull that out. So it's going to be a. Alright, so then you have 1 minus sine squared. That will be cosine squared with the square root. It's going to be cosine of theta. Alright, then let's see, dx is a cosine of theta. So you have another a and another, let's say it's going to be another cosine, so cosine squared d theta. Alright, so we have a sine a square here, so I'm going to actually place this guy in front, and also there's another a square there, so I'm going to place it in front. Oops, sorry. Alright, place it in front. Alright, oh shoot. Alright, so what we get is going to be, actually we have to do the balance, right? So x is originally goes from 0 to a. Alright, so plug it in. So we want a sine of theta to be 0, so theta is going to be 0. Alright, and if you want a, so you have sine of theta has to be 1, so it's sine is 1 and it's pi, theta is pi over 2. Alright, so it's going to be 0 to pi over 2. Alright, then this is going to be, so 9 is still there. Then you have a squared, so there's going to be a to the 4th power. And then you have to go from 0 to pi over 2. Alright, then we can use the trig identity. Alright, sine squared, it's going to be 1 over 2, 1 minus cosine of 2 theta. Alright, and the cosine squared would be 1/2 times quantity 1 plus cosine of 2 theta and d theta. Alright, again we have a constant here, constant there. We can just place it in front, so place it in front there. So we're gonna get, alright, 9, oops, I'm gonna use probably I should use blue here. And we're going to get 9a to the 4th divided by 4. Right? Then we have an integral from 0 to pi over 2. Right? Then if you multiply 1 minus cosine of 2 theta times 1 plus cosine of 2 theta, you're going to get the 1 minus cosine squared of 2 theta. Alright, but this can be rewritten as, right? So this can be rewritten as sine squared of 2 theta. Right? Then we can do the trig identity again, so that we can write it as this is going to be 1/2 and a 1 minus cosine of, you have to double that, 4 theta. Right? So we're going to get this. So I'm going to pull 1/2 outside. So you have a 9a to the 4th over 8. And the integral is still going from 0 to pi over 2. Then you have a 1 minus cosine of 4 theta d theta. Right? Then we can find antiderivative. So you have a 9a to the 4th over a. Antiderivative 1 is theta, minus antiderivative cosine of 4x is sine of 4 theta over 4. Then we're going from 0 to pi over 2. Alright, so 9a to the 4th over 8 is still there. Alright, plug it in, so pi over 2. Alright, plug pi over 2 in, and 4 times pi over 2 is 2 pi. Sine of 2 pi is actually 0, so minus 0. Alright, if you plug in 0, it's 0. And if you plug in 0, sine of 0 is 0. So it's actually everything else is 0. So I'm going to just erase that. And you're just going to get that. Alright, so we get 9a to the 4th pi over 2 times 8, 16. Alright, so let's type it in. Alright, so we got 9a to the 4th pi over 16. Alright, let's check the answer. Submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.